Dear visitors and friends, we continue our conference Startup Village 2021. You can and you should share in social media your participation. Quote our speakers in your pages in real time. And don't forget to mark our account, to link it. But we continue our exploration of the world of technologies, microelectronics and AI, microprocessors, nebulous prospects, or prospective markets. But Dynamo machine is still running. Let's move to the next session. Good afternoon, dear colleagues. I'm happy to welcome you here at this session about artificial intelligence, but we'll not be talking about it abstractly as most do, but we'll be speaking about it specifically, and we have companies here which are involved not only with software, but software for AI is done pretty much by everyone. But we will talk about hardware, and we have designers of chips who in the future can become the basis for Russian AI. You will have a unique opportunity to put questions to them and hear from them. So maybe there will be a machine rebelling, machines made in Russia. So I would like to give the floor Alexey Lavrentiev of Kaspersky Labs, which is a well-known company, which partners with my company as well, and they develop practical devices and hardware for AI. So over to you. Good afternoon, everyone. It's nice to have this session where we can share what we do and what we do it for and how we do it. Kaspersky Lab, in cooperation with Motiv of Novosibirsk, work on the topic of neomorphic processes and neomorphic libraries and approaches, and we try to develop a platform that should help to overcome existing barriers on the way to resolving some practical issues. For instance, it's fashionable to talk about edge computing. Everybody wants to have a smart device which is wearable, which is autonomous. It does not require a megawatt of power. You don't need to have it has some brain power on board. It's able to deal with practical issues. It can be applied anywhere, in industry, in any manufacturing, in mining. Multiple examples for it where it can be applied. Perhaps back in 2016 or 17 we were introduced to Motiv company, and we found a partner in hardware because Kaspersky Lab works mostly with software, and there was this opportunity to jointly advance on this topic, which may become a breakthrough, and there is a demand for it in the market. It's difficult to be a pioneer, understandably, because markets may have technologies, existing technologies, but when you have a new product, you need to do a lot of explaining to potential clients what it means for them, what kind of capabilities they can gain from it. So there are some mysteries there for us on this path. There are some challenges that we try to overcome and resolve, both at software level and hardware level. There are some technological issues. There are some scientific issues there, but there are some prospects that we see. We know what clients will be there for these technologies. I would like to give the floor to Alexei Romanov from Motiv. He'll tell us about the hardware component. Alexei Romanov from Motiv. As Andrei said, since 2016 we've been working on this issue. In 2016 and 2017 we were introduced to Kaspersky Lab, and they invested in ourselves in production of the first series of neomorphic processor. It was called Altai. We did that in silicon in 2019. And so our partnership worked, and in 2020 we got a first series of those chips. They're being tested currently, and we use those chips to assemble accelerators, and they will be delivered to Kaspersky Lab to run practical models and to be able to see how they work. And before that, we tested them using specific benchmarks, and results were very good. They performed well when we use a traditional processor in our prototype, so consumption was half a watt, and conventional devices consumed much more power. So when we talk about graphic processors, so 28 nanometers, that's the technology we use. So I think it's a workable solution. So we are preparing, we are doing some preparations. We also elaborate our software. We develop it for this product, and also with Cifra from Rosatom. It's a subsidiary of Rosatom. So we're testing this on their stand. So this it will be tested there as well. So may you tell me, so we are, this is May of 2021, and you talk about 28 nanometers. Is it too late to create chips that will we will be entering the market with this 28 nanometer technology? No, it's not too late. So we selected 28 nanometers because it's a relatively accessible, broadly used and cheap technology for piloting this. If we move towards finer technologies, of course, processing power will be greater. But 28 nanometers in pure form is not the technology that fits well for battery-based devices because of lots of leakages. So there's some contradiction there. So if I understand correctly, you're mostly focusing on inference solutions. When you process data with neural networks that have been already trained. So you use lower rate arithmetics. No. So the next series of chips, once we work with these, will be with learning on board. So our processor uses a neural technology. We use impulse and spider networks. We have our own compilator. Currently, we have trained networks, any network, and then we have its compilation. It is transferred to our architecture, and then it runs. But your architecture is a good thing, it's great, but a neural methodology is well known. So now in your 28 nanometer chip, to what extent you use those ratios and the practical part? I'm not a developer per se. I'm a business person, so I will not be able to answer that question. Let me try to answer that. So in terms of weights, so they're not just like artificial neural network, it's like 8-bit, 16-bit or 32, but those are weights of impulse. So they have from 10 to thousands of those synapses, but the weight can be 8-bit. So that's about the weight, but they cannot be compared with the weight used in others because it is something else. I understand that. So basically, you want to have your own architecture in the full sense of the word, which is great, but that requires a lot of work. So you will not be to use regular tensors and copy somebody else's model. That's right. You will need to do deep optimization of the model. So mature mathematics and mature development tools will need to be used. Optimization is not exactly the right word here. It's mostly about impulse development, impulse model development and training it. Optimization so optimization means full reworking, complete reworking. I can say the following in response. We're not the only ones there. We're not the only company that does that. And IBM, Intel, they did some of that work. We have some processor, Laihi tuners with onboard learning. There's an international scientific and commercial community that invests in that, and they understand the prospects of it. In terms of energy efficiency and in terms of the speed, because with the regular network you cannot achieve those speeds. And results are somewhat worse compared to state-of-the-art of regular networks. But for practical purposes, they are more than acceptable. But you compete not in nanometers, which has no prospects, but it's methodology of development. That's where you compete. I think that's the most significant result. Colleagues, are there any other questions? So, I would like to give the word to Mr. Burtich. So, iPower is a library, so which wins many awards from Amazon, and Mikhail has a colossal experience in practical development of AI systems, which are used by dozens of thousands of companies around the world. Hello. Thank you for the invitation to participate in this discussion. I see many familiar faces here. Some of the people I worked with productively. I'm working mostly with software, not so much with hardware. But what I see, not when we talk about impulse neural networks, what Andrei talked about, when we talk about standard deep neural networks. So accelerators and specialized hardware for those algorithms, there will be greater demand for them, thanks to two factors. The first factor, we see today that the efficiency of models can be scaled. The more parameters we have, the better the model works. There's a great example of that. Linguistic models, neural networks which are trained to predict the next word. So there is a sequence of words, words, and they can be used to generate news, which sound very similar to real news. And experiments show that if we start with a model that has one set of parameters, and then we bring the number of parameters to 175 billion. So we start with 1 billion. So as the model grows larger, so the ability of a human person to tell the difference between the two, so it decreases. When we have 175 billion parameters, the human person cannot tell whether it's generated by human being or by AI. So that tells us, so this is not only NLP, but also in supportive knowledge, learning algorithms. So that's the same kind of trend. It's not so much about the architecture. You can use basic architecture and just add new layers, add parameters, and the model will be working better and better. And it's not reaching some ceiling. So as long as you have data for learning, oftentimes that's the restriction you face. So that is trend number one. The more weights, the better the quality of model. But of course, the more parameters you have, the more operations are done, the more memory is required, latency is greater, and energy consumption is also greater. If we use that system for real applications and industry, all of that increases the cost of this solution, but we need to decrease costs and also reduce energy consumption. So hardware solutions that help use the specific architecture of a neural network and reduce power consumption, there will be demand for them in the market. And the second factor that I wanted to mention, which is oftentimes missed out on, but it is important. In the last couple of years, we've seen unification of models. In NLP, there's an architecture which is called transformer, and over the last year, many architectures that were used in convolutional neural networks for computer vision, they also produce good results. That means that basic blocks used to build neural networks, if 3 or 4 years ago, they were very varied recurrent networks, direct, convolutional, etc. They were all combined in different ways for a specific solution. So to transfer that architecture for a specific piece of hardware was difficult. Now we see some unification of different types of architecture. So we have the same basic elements which are used for computer vision and also for natural language processing. And that expands the range of their use, and also the use of hardware is expanded. So it's demand-driven. And if you talk about hardware acceleration of neural network, and that's where we're going in the next 10 to 15 years. If I heard you correctly, basically, one of the options for the neural networks that works, let's say it's a news-generating neural network, if you have 200 billion parameters, so it passes the Turing test, so you cannot tell the difference between human text and AI text. So if you talk about Turing test, so if there's a judge that tests that, so he will not be able to pass the real test. But in terms of passing test, like when you have a generated text, then yeah, it's not a real test, but we are looking at the scope. So 200 billion parameters. So for specific tasks, they provide a result which is very close to human intelligence. But in terms of experience, because we look at these extreme examples, but this quality may not be needed in practice. But from your experience, what kind of dimensionality of neural networks is required? So for commercial systems, so what is the scope of that magnitude? hundreds of millions of parameters. So basically, you can say that now out there in the market we have neural networks that provide commercial results from several dozens, hundreds, and from hundreds of millions to tens of billions parameters. So in that range. So from your experience, if users download your library, which is available freely, and it's 6,000 downloads per month. So if you need to create a voice assistant, how long does it take? So from your experience. So when you mean to develop or how much resources are used? Let's say we have a scenario. You have a client. You have a scenario how voice assistant should work. And you have all the input, you have data, and it should be adapted to work with your library. And it should be, and then algorithms, top-level algorithms should be connected to manage the conversation scenario. It depends on the complexity. It may take from a week to several months, depending how difficult that task is. But as an example, I can say
that a year ago, Digital Tatarstan, the team has shown a very interesting number. These are very interesting and active guys, and they took our library, and in a couple of weeks they created a solution for consulting people on COVID-19 when all the hotlines have been overwhelmed, and they created this automation. In a couple of weeks, you can do something more or less okay. So basically, let's say 1 month for a very specific task and with a good team. So we can have some task that can be solved. And this way we will solve this task, right? So just to have an extra time, right? Yes, dear colleagues, any questions? You can see a person who has been able to make a great contribution into the development of the speaking AI in the whole world. I'm not afraid of saying that. No questions? Okay. I'm not going to be a moderator right now. Let me add something. So our design center is working with Pavlov's team, and in some way he is working with Pavlov team, but from the point of view of hardware vision. So if we're talking about the technical point of view, there are 3 classes of neural networks. First of all, this is the machine learning, deep learning, or whatever you call it, various variations. This is all about teaching the neural networks. There is a class of tasks when the neural network has been already studied, and it's processing the data. This is called inference, and a new class has appeared just recently. These are edge solutions, which can be viewed from 2 points of view. First of all, this is the initial processing of the data in order to transfer it to the cloud environment for processing after that. So in this case, we're talking about smart speakers which are processing and compressing the voice into the form which can be recognized. But there is a more interesting task in the recent times. The neural network of everything will not be ever created as we see it. Any commercial solution is consisting of several neural networks, and it's very important to pre-process the data and to understand which neural network has to use it to process later. This is the modification edge. And we are working with a solution with the inference markets. We are orienting ourselves for classic neural networks with lower bit rate and 8 and 1016. And the thing is that we are first of all thinking about the solutions of clusterization technologies. As the first people who have been speaking first, we are not trying to break any records on nanometers. So 28 nanometers is indeed rather available technology, but as a technology for mobile devices, it's not optimum. However, for server things, it's quite okay. We believe that the task of building a super chip is not a proper task. We believe that, first of all, we should think about the ways of building networks out of the chips, which should be almost unlimited, in order to grow the capacity based on the demands. We have five levels of the networks: crystal network, crystals which are based on special platform in the core, in the body of the microscheme. So the plate and interplate network in the body, and of course the stack network, which is based on a big supercomputers. There is a very big, good, interesting solution, NVIDIA, great solutions, which are using Mellanox products. We are working with it as well. There is a Russian interesting development called Gora, the mountain. Needs have to, the people are still breaking the records on latency, and we believe that this is a great approach compared to creating a super chip which would have 100 computing cores which are doing whatever they are doing. But there is a peculiarity, so all the creators of the micro schemes who are talking about the amounts of cores are not talking about the efficiency of these solutions to perform particular tasks. Company R, for their accelerators, are saying that for some networks they achieve 85% of efficiency. Basically, 85% of these elementary nodes are performing quality work for neural network tasks. This is a great value, but even for their own developments, in ARM is talking about only about 2 or 3 types of accelerators, and there are lots of those. And NVIDIA, for example, is keeping silent, and you cannot evaluate which ones out of 16,000 cores are actually working. And if we're building the super chip, there has to be a bus on inputs and outputs, and of course the memory as well. So we can build 20 and even 64 calculators. However, the question is what they're going to be doing. So what is going to bring the data, where the memory of coefficients is going to be stored, how we're processing the data, and so on and so forth. That is why we believe that the size of the chip has its limits. And if tomorrow we will have 2 nanometers technologies, it won't be exceeded. And we believe that for very serious cloud-based solutions, the key thing is the clusterization, where we are actually heading to. We are dividing those notions. We understand that the end customer doesn't want to teach the neural network. Neural network has to be taught separately, and it has to be solved in a specialized complex. The perfect solution is to have the cloud-based complex for it to be most efficient, for every possible team to just rent time for this complex and to teach the neural network which it needs to teach. And then inference task is a more simple ideologically, but from the point of view of hardware, it's not that simple. These are the solutions which we're working with. If you're interested, I can answer your questions. Yeah, I have a question to Mikhail, actually. So the Pavlov is very popular framework. The iPavlov is a very, we know it. So the cluster is built on NVIDIA, it's big. And an example from Tatarstan, when people took a framework, they just rolled it out and started to provide the services of voice assistants. It's all about the load and capacity, how to use the network and which networks should be used to launch it. I'm thinking about more complex things here. What is your experience in this regard? Well, the situation is getting a bit simpler because we are using the pre-taught models. Most of the NLP tasks are solved by additional teaching, by additional processing and configuring. And the more the model, the better it's learning based on the specific example. In this regard, in order to teach a model, we need to have a lot of resources. We have been using DGX server with 8 digital cards, and for it to learn the language model. However, later on, when it's taught, you can actually download it and you can launch it in CPU even without the graphic accelerator, and it's going to be working rather fast, and it will be able to process requests in production with batches, with several batches in one request. Of course, if the load is more, you should be using GPU. But all of these are the models which do not require great expenditures here and now. If I understand you right, so the multi-core processors can use iPavlov, so for even we do not even need the hardware acceleration without GPU and to launch the products of iPavlov, right? Because sometimes you don't need this super capacity. Yes, there is a image of Docker's needed library. So, and there is a version for GPU and CPU. So GPU was downloaded 10,000 times, and CPU version has been downloaded more than 1,000,000 times. People prefer to use it on CPU. The container with CPU version. Thank you. A couple of words from Alexey Alyasyev. He is willing to rush in. He is representing the high-tech company. They are developing micro schemes of hardware acceleration for the tasks of AI. High-tech has classic ideology. They are talking about the matrix of computing hardware, and let's think how the basis for Russian Skynet actually works. Thank you, Evgeny. Our company has been working in the field of development of hardware accelerators for 4 years, and I don't want to speak about specific things about the architecture and the processor and so on. I would just like to speak more about wider things, about the products which are formed based on the microelectronics which we receive after in the process of this development. The situation is as follows. Just like motive and module, we started this development before it has become mainstream, before the artificial neural network has become mainstream, but of course it has been developed before as well. The tasks ahead are already formed and they demand solutions here and now. And I have been asking Mikhail some questions. There are leaders in the world on the availability of the computing resources. This is NVIDIA. You cannot buy anything else in order to teach the networks. And for inference, we are talking about CPU, and nothing better than Intel can be found, maybe AMD. In fact, we do not have any real projects in the world which can offer neural accelerators. To offer neural accelerators at all, like NVIDIA, which would be great on their processing powers, which would be competitive in their price and in their efficiency. This is more or less monopoly, and in this particular case, we can see the development of many organizations in the world, in China, everywhere around. Everybody wants to take up this niche because, in fact, all the other niches, CPU and computer graphics, already see great leaders which cannot be competed by whole countries. In the field of accelerations for neural networks, if we're talking about standardization, which is being formed by the neural networks themselves, Mikhail mentioned it as well, and we are working in the technical committee on this as well. We are looking at how it happens. Right now, we already can see transforming, which are going to affect the development of the next dozen of years. And this is the field. So Russia and our company are going to be able to be in this field on very high positions, and maybe now or a bit later we are going to form a kind of a standard of the computing modules for classic neural networks. This is very important because these capabilities for any companies are very important, and these capabilities are not provided to the companies here and now. So of course it has been forming for quite some time, but right now it's on the rise. This is a new trend on the computing capacities for AI. And it's very important to mention one thing. At least it's great to say that in Russia our company and other organizations are ready to invest their money, their efforts and time to become the pioneers in this particular field, and this is very important. Also, we have been talking about this in Skolkovo, and of course, attracting investments into this field is going to return its investments in the future tenfold. We are analyzing the products which can actually return investments here and now, but it's very hard to find those. We have several formed fields and areas: recognition of images or machine vision, something which is used here and now, something which brings the results here and now, but these products sometimes do not return their investments, at least now. It is quite obvious that artificial vision and recognition of the natural language are going to be the dominating technology from the point of view of organizing any business and any technological process. In fact, this is going to be an integral part of any work, and we are going to form the main competitive advantages of companies based on that, and the companies are going to be ready to pay for these technologies, to pay the money to the developers of the hardware accelerators and developers of neural networks, to this community which is teaching the neural networks and modernizing it. And we would like to highlight one little thing. Russia is developing this field rapidly, and we can see that there is a huge area of work which is going to give great advantages in the future. Speaking about architecture itself, right now we can see a battle taking place. Everybody is competing about this, but approaches are more or less the same. Everybody is looking at the results that can bring any return of investments in the production. I'm talking about the hardware complexes which are recognizing the speech, sounds, optimize the parameters, or create some recommendational systems or whatsoever. And this is basically laying the foundation for the future work. In this regard, I cannot say that we are the best or somebody else is the best. However, this trend is formed in Russia for sure, and one of the several best systems are going to be developed in Russia, the systems which are going to accelerate the AI. We are working with world community very closely. We have been working with the International Association, PERCA, which is, as Evgeny said, which is comparing things on parameter-based. And of course, everybody is trying to be better than everybody else. And there are already standardized tests on the efficiency to test the hardware complexes, and they are checking the neural networks as well. These are standardized, and they are out-of-the-box systems, and you can use them for production. And after that, various architectures, I'm talking about chips and many other things as well, architecture of the whole complexes, the speed and the velocity of all the systems are using the key parameters of the neural networks, and we are talking about the accuracy of the results which are giving the production and efficiency, and the delays which are actually becoming lower and which are showing great results. Many algorithms of the technical vision are, first of all, the production processes, the autopilots with the delays of milliseconds are actually rather big delays, and this is very important. We need to shorten those. And over here we can see great potential for new architectures, for new complexes, including our colleagues and ourselves. And we really hope that we will be working and competing with our chips and hardware complexes on the international level. I would like to draw your attention to a very important thing. During all the commissions on the AI, I have been always talking about the Union for Standardization. Yes, we have lots of organizations in Russia. They are commercial organizations which are following the commercial interests, and it would seem that sitting them at one table could be actually the crime from the point of view of taxation departments, or it's going to be impossible because they are going to fight each other. But we do understand that this is not the future. But however, there are things which we have to solve together. If we are going to blindly copy the Western technologies, we won't create neither natural intellect nor the artificial one. We have to create our own methodology, which should not decline the competition and the commercial interests of the companies, but we shouldn't do it so that different companies would do the same things, spending their own money for the same thing. Some methodology has to be done, and it has to be supported on a state level, and we need to configure those things. We need to involve some know-hows brought by every single company, and this should be the tool of returning the investments, and we won't achieve anything without this. And another important topic: we have not been the first to start here, and we have a chance to learn from somebody else's mistakes, and we're going to use this opportunity. I would like to give floor to Ilya Savenkov, representative of Module company. Module is a very important company for us. I remember that in 2000 I have seen the architecture of neural matrix created by Module, and it was 64-bit DSP. And speaking about the hardware provision of the system of the AI, this Module was a great company, and it still is.
In fact, I wanted to support what Alexei said. During this discussion, I was thinking, what should I mention? So these are major companies, but this market of AI, of working with big data, or the market of neural networks with different types in verification. So this is a fairly new market for us. We have an effective partnership, non-commercial, with high-tech company. So they tested our solutions and vice versa, our hardware. We are both happy with each other. In terms of artificial neural networks, and as a standalone company, we take existing chips that have our DSP on board, the fourth generation, with floating and fixed points, and we try to run on them those neural networks that customers consider to be popular. So we have clients in the closed or double segment, but with some difficulty, we also find sectors of civil use, video analytics, medicine, access control systems, etc., etc. Medicine is a whole different area. Even from the legal perspective, we are at the edge of global experience. Even Europe is not ready to certify medical systems with AI elements, but we are making attempts to do it, being second after United States and FDA, which oversees that. The first software product was already registered. And we work with those guys. And here's what we do to develop it. We have a roadshow. We have our neural hardware pieces with our component base, which is implemented using topological norm of 28 nanometers. It's not the fully optimized technology for edge technologies and verb devices, but we were able to reduce consumption by down to 2 watts. So I think crystal size is 9 by 9. So it's really not that small, that crystal. And so that's what we had back in 2016. But silicon produced in 2016 was quite effective for some of the tasks. When we put on our architecture a wide range of classes of convolutional networks, we also discover STS networks in cooperation with Bear. A lot of time was given to this discussion related to NLP and with audio information, but we never specialized that. We specialized in image recognition. Video and images are what we focus on, but we are open to experiment. Some things work, some things don't. But going back to medicine, we discovered that for ourselves, this area of medicine. It's not even a market yet, but there's so much demand there. So we should not fight. We should be at the same table, and we should organize we should have a productive discussion. And one of those things, so the weather is great today, and we're at Skolkovo. This is one of the places. And then regulators who have the mandate to regulate this ministry. So the Ministry of Trade, of Industry and Trade, and various departments. So we're so few yet, so it's too early to speak of competition. I think we should find comfortable niches for ourselves, occupy them, because colleagues have particularities of their architecture, and they can work with specific networks. And we have classical DSP, others have tensor-based neural networks. So applications are numerous. So we should join our hands, figuratively speaking, make friends and meet each other and learn about each other in our technologies and continue doing this. And perhaps we will use one super microchip, even though I'm not in principle against it. But a large microchip should have large handles, so we will be able to carry that. But material science is developing, so we will not need those large handles. That was important thing that you mentioned about electronics getting obsolete. So microchips produced 10 years ago. So I give the floor to Alena Dorbashevskaya from Yandex Cloud. Yes, colleagues, good afternoon. Thank you very much for the invitation to this session. I'm sorry for doing it remotely. I see that our time is up. I don't know if I have a chance to say something. Yes, we can hear you. We hear you. At Yandex Cloud, we have an interesting situation because we develop technologies, as was mentioned today. So synthesis and speech recognition is that's one of our products. Besides that, we work on image processing, we deal with translations, and we use new technologies and new approaches ourselves. That some of them were mentioned today, specifically when we talk about speech recognition technologies. We basically transferred our architecture to transformers because quality was really improved as a result. At the same time, what is interesting, as a cloud provider, we also want to be helpful to other market players because people come not only for technologies and they join Yandex Cloud, but they need a platform and tools to resolve their issues. So we talk about major companies and startups. So in that respect, we are trying to provide such configurations and clusters which are optimal for different classes of tasks. So end users do not necessarily need learning, but a lot of our cloud users are development companies, and they need to have servers for training purposes. So we look at the market, at its needs, and accelerators like NVIDIA processors are needed, like Intel processors, ARM processors, and we provide different configurations and servers for different purposes. So I wanted to be very brief, understanding that we're out of time. Thank you very much. Yandex is a company that is clearly provides services to us, and it uses AI, and their experience is great and invaluable. I would like to give the floor to Alexander Suetin, who represents the Skolkovo Foundation. He understands the general picture, so how AI is practically used, and he will help us to get on the right path. I'll be very brief. In fact, we do hope that more and more companies will be developing specialized solutions. It's difficult to compete with hardware, so you need to have access to the tools. And the Skolkovo Foundation can provide those tools to you from leading companies. You can use all the list. You can look it up on beneficial terms. And you will not be able to get that access at that price. Also, we actively work on the federal project on AI, and there's a major component there to develop hardware solutions, but specialized hardware solutions. So a tender will be held, so why not participate? It will be done by the Ministry of Industry and Trade. So in terms of funds, not a lot of funds, but it will be good for your first step. So this federal project is advancing, and hardware, software systems will play a major role in it. If we talk about social aspects, I'm somewhat pessimistic, especially after the conference that recently took place, Google conference, where they announced that their own processor, the fourth version, nobody even knows like how many they have of them. So supposedly they have several rooms with specialized processor, and energy efficiencies is better by several orders of magnitude. So I don't know how colleagues from Yandex can compete with that, because if you use those cards and for learning purposes, I'm not sure how it's going to work. You should be more creative and try to find niches and develop your own solutions which are competitive in the market. So this is what I wanted to, that's a challenge I wanted to give to you. As a moderator, I would like to stress the key idea today that the Russian market of AI requires unification. We should develop our own national methodology of development of practical AI systems, develop our own engineering school, programming school, scientific school, so that not to follow in a different way, but to have our own competences in hardware and software, and most importantly, we should set our own objectives and achieve those objectives. Thank you very much for your attention.
Жажда веселья. Жажда путешествий. Жажда общения. Утоляй любую жажду с освежающими вкусами Липтон. Мой любимый персик.
При низких температурах окружающей среды тела быстро теряют энергию. Но нахождение вблизи источника тепла позволяет телу получать тепловое излучение. Происходит самопроизвольное перераспределение тепла. Следовательно, когда источники тепла находятся вместе, их энергия побеждает холод. Лучшее создается вместе. Газпромбанк.
МТС Стартап Хаб. Работа с реальным бизнес-заказчиком МТС. Доступ к ресурсам самого крупного телеком-бренда в России. Не можешь поверить? А в твой стартап обязательно поверят. У нас есть все, что тебе понадобится. Ресурсы, клиенты, технологии, каналы продаж. Мы оценим твой продукт, правильно применим в своем бизнесе и масштабируем на мировой рынок. МТС Стартап Хаб ждет тебя и твоих нереальных бизнес-идей.